The first topic we're going to discuss is angles. So we have a few definitions here, and you might want to pause the video to get them down. The first one is trigonometry. So that's the relation of sides and angles of triangles. And that's really, we think of SOHCAHTOA when we think of trigonometry, right? Sine, cosine, and tangent, where we're looking at the sides of a triangle. An angle is determined by rotating a ray about its endpoint. So we saw this in the summer packet, and you'll see that we have our initial side, which is the side along the x-axis, the positive x-axis. So that's my initial side. We also have a terminal side, and that is the ending side of the angle. That's this one over here on the left, and that's my terminal because that's where the angle ends. And then we want to make sure that we are also including that arched arrow that we had discussed in class to make sure we know which way we are going from initial to terminal. So this is showing a positive angle because it is going up, but there's also negative angles. And we also see that we have a vertex, and that's that point right there on the origin. So it's our vertex of our angle. When our angle is in standard position, you'll notice that the origin is the vertex and that the initial side coincides or is on the positive x-axis. And then we want to find the measure of an angle. So that's determined by how much rotation from the initial side to the terminal side, and that's that arched angle we have going on there. We can really, what we're thinking of this as being is a central angle. Later we will put these angles on a circle, so these will be a central angle where the origin of the graph is the center of the circle. These angles can be measured in two ways. We have radian or we have degrees. So radian is the measure of a central angle that intercepts an arc S, we call it S, the arc length, equal in length to the radius R of the circle. So the arc really is the same length as the radius. So in a circle, we will find that there are 2 pi radian in total, so that's a little bit over 6. So one full revolution is going to be 2 pi radian. We don't need to write RAD, but if you did want to abbreviate, that would be the way. It's understood to be in radian unless we put the degrees bubble. For degrees, that's just another way to measure angles. For example, like 45 degrees, 60 degrees, that sort of thing. 1 degree is equal to 1 out of 360, so 1/360th of a complete revolution. That's just another way of saying 1 complete time around the circle. So we know there are 360 degrees to complete an entire circle. Then we want to talk about the unit circle. So the unit circle, why are we going to call it the unit circle? Well, we call it the unit circle because it is a circle with a radius of 1 unit. And we talked about this very briefly in class, but we will, we'll continue when we were talking about the summer packet with this. So our unit circle can really be thought of a few different ways. We can look at this as radians, we can look at this as degrees, we can do this a few different ways. So let's start off with degrees, and it doesn't really matter what we start off with. All right, so for degrees, we start at 0 degrees here on that initial side, right? That's where we would draw our initial angle. We know that the entire circle is 360 degrees, so we could also say that this is at 360 if we were to go all the way around the circle, right? Okay, so if we go halfway, half of 360 is going to give us 180 degrees. That's our halfway on the circle. If we go halfway between 0 and 180, that will give us 90 degrees. Okay, and if we go halfway between 180 and 360, that's another quarter of the circle. That'll be 270 degrees in total. Okay. So now if we continue, we'll go to 45 degrees, which is halfway between 0 and 90. And if I kind of do that each way through, we've got the halfway point or the halfway mark in each of these angles. So really it's just going to be halfway between, right? Halfway between 90 and 180 would be 135 degrees. Halfway between 180 and 270 would be 225. And halfway between 270 and 360 would be 315. Okay? Now, if you notice the other parts, they're chunking each quadrant into thirds. So this is a third of the quadrant, and this is breaking it up into another third of that quadrant. So there's a third, here's a third, here's another third. So a third of 90 will give us 30. And if we add another third to that, that's 60, and then another. Okay. We could kind of do the same thing if we're breaking it up into thirds. That's 120, that's 150. And again, we have thirds all the way around, 210, 240, 300, and 330. Okay. But another way to look at this, and in my opinion, the easier way to look at this, and that's why I prefer radians, is to look at these as fractions. Okay. So if I take a look at my graph or my unit circle, I'm still at 0 radian over here, but we said an entire circle is 2 pi radian. Half of that circle would be half of 2 pi, which is pi, which is how we got 180. Half of pi, so instead of going from the initial to 180, if we went from the initial to up here, half of pi would be pi over 2. I'm just going to use these lines as fraction bars. Okay. So this is pi over 2. This is the same amount, so that's another pi over 2. So that's 2 pi over 2. That makes this down here 3 pi over 2. I'm running out of space. 3 pi over 2. And then that would make this 4 pi over 2, which simplifies to 2 pi. Okay, so we're getting there. So now we want to keep thinking about this as fractions. So let's think back to this pi over 2, okay? We have a halfway mark. Whoops. We have a halfway mark on here. So that's really taking this pi over 2 and cutting it in half. So pi over 2 divided by 2 is really going to give me pi over 4. Okay. So really this is pi over 4, so like 1/4, 2/4. This is that same measurement, so that'll give me 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. That'll give me my 2 pi again. Okay, same logic. Let's cut this into thirds. So instead, I've got a third. Okay, so we're taking our pi over 2 and cutting it into thirds. That'll give me pi over 6. So here's a third, here's another third. That's pi over 6. 2 pi over 6, which is actually pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6, which simplifies to 4 pi over 3. That was 8, so this is 9 pi over 6, which simplifies. What are we up to? 10 pi over 6, which simplifies to 5 pi over 3. 11 pi over 6, and then 12 pi over 6, which is 2 pi. So the radians are really just cutting the circle into fractions. Okay. Really, if you think of it as cutting the semicircle up, that can help a lot. We'll get to these points in a little bit, but we're not quite there yet. So we can think of this, like I said, as degrees, or we can think of this like radian, and it is very useful to start to get familiar with each of these. Okay, so the next thing we're going to talk about is graphing angles on here. So we can graph positive and negative angles, and we said standard position. Remember, standard position means that we are on the vertex is on the origin, and the initial side is on the positive x-axis. And we did some of this in the summer packet. So we know that for positive angles, we go counterclockwise. We go up first, right? And for negative angles, we go clockwise. So for positive, if we have an angle, we're going to go up. For negative, if we have an angle, we're going to go down. Okay. All right, so let's just practice sketching some of these. And you might want to pause it and try some on your own, and then we'll come back. You know, you can start back up again and see if you, if you got what we have. So again, origin every time and your initial side. That should be for every graph. If you want to take a second to fill that in, feel free. You can use the unit circle that we were filling out before to help us with this. So the first one is pi over 6. That will be 1/6 of the entire first half, the first semicircle. So that should be about here, and that's my pi over 6. 3 pi over 4. Again, remember, a full pi is half of the circle, so that's 3/4. Should be about here. 2 pi over 3 should be about 2/3 of the top half. So, whoops, that's a terrible line, sorry. If this is pi over here, so 2/3 should be about here. 7 pi over 6, that is more than a full pi. So if this is full pi, 7 pi over 6 is like 1 pi and 1/6. So that would be somewhere around here. Pi, we know that one. That's on the left. Pi over 2, another one. We call these quadrant angles because they are on the quadrant lines. Okay. 270, again, very similar. We're going to have that initial side, and then our terminal side is down below. So there's my 270. Okay. 225, again, you might want to use the unit circle to help you out here. We do know that 180 degrees is over here. We do know that 270 is down here, so it has to be somewhere in between. Positive. 360 is an entire circle, so my terminal and initial are actually on top of each other. And 3 pi, I think we may have done in class for the summer packet. We have our initial, and we're going to go around 1 pi, 2 pi, 3 pi. Okay. Or you can think of this as saying, okay, let's take a full circle away. That means we go around 1 time. And how many more times do we have to go? 1 pi. Okay. Negative pi over 2 means that we need to go down. So pi over 2, we're kind of just reflecting down below. There's my negative pi over 2. Negative pi over 4, same concept. It would just be a reflection. Negative 2/3, again, same concept. So we have our initial. We're going to take down 2/3. 11 pi over 6, that's almost an entire circle, but it does say negative, so we're going to go down first. So all but 1/6 of the circle, right? 12 pi over 6 would be 2 pi. And then negative 3 pi over 4, so negative 3/4. That should be about here. Okay. The more familiar you are with the unit circle, the easier graphing these will be.